In the next lecture video, we're going to be looking at gas laws and chemical reactions. The goal is to apply the gas laws to study the stoichiometry of reactions. So here we have a balanced reaction. A moles of A reacts with B moles of B to give you D moles of D and E moles of E. So remember, the key to going between one substance and another, regardless of whether it's A to D, A to B, B to D, or whatever, in this case, I'm going A to D. The key is that we need moles of A to get moles of D, or vice versa. So we learned first that you can get moles of A using the molar mass of A if you start with the mass of A. You can get the moles of D if you have the molar mass of D. So here I'm going to put mass of D and mass of A. So that's how you get to moles of A. We also learned from the solutions lab, or the aqueous solutions lab, that you can get the moles of A if you multiply the concentration times the volume. And likewise, you can get the concentration or the volume of D going this route. But we also learned in that lab that you might start with the mass of A and actually calculate a volume of D that you use for this particular reaction. Well, now we have a new twist. You can actually calculate the moles of A if A is a gas using the ideal gas law. So the moles of A is going to be PAVA over RTA. And the same here with the B, or I should say D if it's a gas. So let me correct that very quickly here, because I have B there, and that should be D. D for dynamite. Okay, so let's take a look at a problem involving this. And here we go. So gas laws and stoichiometry. Hydrogen gas is produced from the reaction of lithium and water. What mass of lithium is required to produce 23.5 liters of H2 gas at 17.0 degrees Celsius and a pressure of 243 millimeters of mercury? So what I'm going to do here is I'm going to write the equation out again. 2 lithium solid plus 2 H2O aqueous gives you 2 lithium hydroxide aqueous plus H2 gas. Okay, so that's what we're given as the balanced reaction. We're also given a number of things here. So we want the mass of lithium. So I'm going to put right here grams of lithium, which means I probably am going to need moles of lithium somewhere along the line. Is required to produce 23.5 liters. So 23.5 liters, that's my volume of H2 at 17 degrees Celsius. So that temperature is going to be 273.15 plus 17, which is going to make it 290.15 Kelvin. And this is only good to the 10th. And a pressure of 743 millimeters of mercury. So you can see here that if I had called this a V1, a T1, and a P1, there is no V2, there is no T2, and there is no P2. So that means I want to use the ideal gas law here. Which is PV equals nRT. And so naturally here, if we want to know what mass of lithium is produced, we're going to have to get the moles of H2, which will give us the moles of lithium, which then can be used to get the grams of lithium. And how do we get the moles of lithium? Well, we use the ideal gas law. Okay, so here it looks like we want to do this in 2 steps. Let's use the ideal gas law first. So we're going to take PV equals nRT. And since we want the moles of H2, we're going to rearrange this and write it as such. N is equal to PV over RT. We'll plug the numbers in. The pressure is 743 millimeters of mercury. The volume is 23.5 liters. For R, we want to use the one with millimeters of mercury in it. And let's see, that's the one that's that's the one that's 62.4 millimeters of mercury per mole per K. And then we're going to want to put in the temperature, which is 290.15 K. So that's going to get us our moles of hydrogen. All right. So let's see what we get here. And I'm going to estimate again. So let's see. I'm going to do this. 62 will go into that about 12 times. 12 times 23, I don't like that anymore. I'm going to do this differently now. 23 will go into that about 3 times. 3 times 290 is around 900. And 743 divided by 900 puts me at around 0.9 or 0.8, something like that. So let's see what we get here. 743 times 23.5 divided by 62.4 and divided by 290.15. And we get 9.6 or 0.96. And let's see, 3 zig figs, 0.964. And that's going to be moles of H2. Now, if we wanted to, we could have continued this already, but what I'm going to do here is I'm going to write this down here at the bottom. And now I'm going to do this part here, and you can see that for 1 mole, there are 2 moles of lithium. And then we're going to find the molar mass of lithium. And I want to say it's 6.941. Yep. 6.941 grams of lithium per 1 mole of lithium. And we will get grams of lithium for this particular reaction. Now, estimating this, I think we can all agree that that is pretty close to 1. So that times that is 2. So 2 times 6.9 is going to put this close to 14, but a little less, so we'll call it 13.5. So let's see what we get. Times 2 times 6.941, and we get 13.4 grams of lithium. And that's how you do stoichiometry with the gas problems. More than likely, you're going to have to solve for the moles of the gas and then do something over here. All right. Well, that was a pretty short one. Thank you for listening.